I love JavaScript, but today, since it's April Fool's, I thought we'd take a look at some times where JavaScript feels like it's taking a bit of a joke at you and making your debugging experience so much harder with some of its oddities and quirks that JavaScript has that we've all fallen foul to during our time as developers. We're going to take a look at some of the most popular ones and a bit of explanation behind the scenes as to why JavaScript actually does these odd things. So let's jump into it. Now, the first one I'm going to show you, I saw this one on Twitter. I'll leave a link to the original tweet down below. But essentially, it's saying if we do a regex expression and then test it on an object and test it against mum or test it against dad, what happens? Well, you'll see here we get true for the first one and false for the second one. So when we run that, we're saying basically that the regex matches, whereas for this one, it doesn't. The reason for that is actually this object here, it gets converted to object brackets object, so it gets converted to a string. And then when this does this test here, all this is testing is one of these characters in the string that you've passed it. And since O is in object, it comes out as true for that. And then since none of these are in that object string, it comes out as false for that. The next one is another really fun one, and this has been an example with foobar as well. But if we do B plus A plus A plus A, what we can actually get out is banana. And this is because that plus A bit here, so this bit here, actually converts to not a number. And then when we do the not a number plus another string, it then goes back to string concatenation. So it adds in not a number to your string. So you actually get the string banana out of this. Next one we'll take a look at is double dot, which might seem a bit weird to people. But if we do like this, let's say we did 69.toString, you'd see that we'd actually get an error. But if we just add a second dot there, it will do it perfectly fine for us. And as it said here, it's because that dot character represents a bit of ambiguity, because how does it know whether we're going to call that toString or whether we're talking about a decimal point? And then just adding a second one there clears up that ambiguity, so it knows that this toString then should be run as the actual function there, so it allows it to be run. Next one's a really cool one, which is that HTML comments work in JavaScript. I'll be honest, I didn't even know this one, but here we go. You can actually just use it. Obviously, a lot of editors these days will find a problem with it, but this will technically run on the web or where you're using JavaScript, even in Node. The reason for this was really old browsers like Netscape, but it has since been adopted and it's in the Node.js runtime as well. So there's just a really cool sort of example of really, really legacy sort of support for things, but it has been added into the spec. Next one is you can call functions with backticks. Now, you may have seen this before, but you haven't actually realized what's happening, and that's if you've used styled components in React. So here we obviously have this subscribe function, and we can run it with false. So if we're running that with a false, what you'd see is we would get you are not subscribed, but then we can also run it like this, passing through true as the parameter here, just using backticks straight after our function there. As I said, you've actually seen this syntax if you've used React style components before. Next one we're going to look at is a constructor. What's going to happen if we run all of this? Well, you'll actually see that it's just going to console log WTF. Now, the reason for that is we first define C as our string here of constructor. And then on C, we then do C, but then in C, we get the constructor property. So since C is a string, we get the constructor of a string, which is a function. And then we get the constructor of a function, which is a function. And then when we use something on that, it's essentially outputting the function itself, so we can then run the function, and then that's what this bit here does, and that console logs WTF. Yes, that's extremely confusing, but it does make a lot of sense. As I said, you're going up the levels of constructors, finally getting essentially the function constructor itself, and then running it with this console.log here. It's essentially how JavaScript works, just really confusing. You probably would never see this in the real world, but it's just a really cool example of some weird quirks you can do with JavaScript. The next one isn't really a quirk, it's just some things that people don't really know about, which is we run this here, you'll see that we'll only get that first console log, and that's because we're using JavaScript labels. Not too many developers actually know about labels or use labels in their day-to-day, but you sort of get into them if you started to do a lot of loops or a lot of blocks where you need different things, and it gets confusing to keep track of which one you're breaking out of, and that's where labels can come in really handy. So as you can see here, we've just labeled this block here as foo, so this block here is foo, and then we can break out of that instead of doing return or something. As I said, really useful for things like loops. The next one is a quirk with try-catch that some developers fall foul to. Again, it's not really a bug or a quirk or anything, but some developers may not understand it fully when you're starting out, which is essentially when you use the finally keyword, it overrides any return value that you've already done. So we do return 3 here. You'll see, even though it could simply return 2 as it's doing a try block, but obviously we're returning straight away. There's nothing really to try there. It should be able to return 2. But the finally is always going to override that value. So always going to get 3 as the output there. The next one is a bit of a tricky quirk with JavaScript, which is the return. So if we ran this, you'd see we get nothing back as a return. However, if we now change this to look like this, you'll see that we get back what we actually wanted to return here. As it says here, this is all due to automatic semicolon insertion. So when we had it like this, a semicolon technically would be inserted here. So it would look like this instead, meaning this code here is unreachable. But when we put it all on one line, obviously it doesn't do that. And it knows we're now starting an object, so it can return that. Again, just another one that you may have been caught out by before. But again, things like prettier and all of that, linters and stuff, may help you catch that for you. The next one's an infinite timeout. So if we set a timeout for the timer of infinity, what's going to happen here? Well, what actually happens is it gets returned straight away. And the reason for that is because delay is converted to a 32-bit integer, but when you have it as infinity, it causes an overflow, which means infinity then becomes 0, so the callback is called immediately. A lot of the time as well, this may just crash your kernel or whatever you're using. Next one we have is one that has plagued developers for ages, and I've seen so many funny debates about this on Stack Overflow and Twitter and various things, and that is that not a number is not equal to not a number. And the reason why not a number isn't equal to not a number, as it says here, is because not a number is the only value in JavaScript that's not equal to itself. That is literally the definition of it in the spec and in the standard, is that not a number is not equal to any value, including itself. But the next thing that also trips people up is that not a number is a number, which is also a bit confusing. So the type of not a number is a number. And again, this is all just down to the spec. As it says here, not a number represents an invalid or undefined result of a mathematical operation. Despite its name, it's technically a type of number in JavaScript, and it's technically a numeric type. Again, another thing that I've seen so many great debates on and just a lot of confusion around, but it's just one of those things you have to learn and one of those things that's in the spec. Next one we have here is that an array is equal to the false value of an array, which is a bit weird. As you'll see here, this is a breakdown of what actually happens with the expressions. We've got the sort of explanation here, but what happens is we get the array here, it converts it to 0, and then it converts it to the other side, 2 plus false, and then this side gets converted to 0, 0, and then 0 obviously does equal 0, so you get true out of that. So it's all to do with how the types are coerced in JavaScript, and pretty much most of these errors all come down to some form of how a type is coerced or how it's interpreted by JavaScript. Similar problem here is obviously an array is truthy, however an empty array is not true. So we've run this here, what you'll see is we'll get true for this. So if we take an array and then we essentially convert it to a boolean here, you'll see that we get true. But if we then compare an array against true, and this isn't a strict comparison, it's technically false. And the same thing happens if we use null as well. So if we convert null here into a boolean, we get false. And then if we say null is equal to false, it's not. So null, again, is falsy, however, it's not false. Just some things that can really throw you up, especially this null one when you're doing comparisons or checking for things being null or false. It's a one that definitely confuses people. And as you can see down here in the explanation, it's all again coming down to that type coercion there, where the type array, primitive value, in this case, it's an empty string. When comparing a string with a boolean using that, JavaScript converts the boolean to a number where it becomes 1. And since an empty string is not equal to 1, this is what we end up with. So we get this up here. The next one is that true is not equal to an empty array, but it's also not equal to an array either. Again, another really tricky one. So as you'll see here, true prints out false here. It's not equal to an empty array, but then true also isn't equal to the false value of an empty array. So what is an empty array equal to? And again, you can see the same thing here where false is equal to an empty array, but false isn't equal to, or it still is equal to, sorry, the value or the converted value of an empty array. Again, another really confusing one, but it does come down to, again, that this will be converted to an empty string. And then when this is converted to an empty string and we do this check here, what you'll get is true is equal to, this will be an empty string. Since an empty string is technically still a truthy value, what you end up with is false here. So it comes out as true is equal to false. Another really confusing one there. One that can catch people out, but again, this one actually makes a lot of sense to me, is that false is equal to true. That's just because if we convert it to a Boolean here, all it's going to do is look at this string. It's not going to look at what's in the string. It's just saying, hey, we have something inside of the string. Since we have something inside of the string, it's a truthy value. Let's convert that to a Boolean. So this is true. And then that same logic applies here. This is true. It's not reading what's inside that string at all. Another really cool one to take a look at is this, and this is just, I love this, and there's a website that I'll link in the description below where you can make your own version of this. But essentially, if we run this code, what you'll see is we'll get the text out fail. So we console logged all of this, we would get fail. And again, that's how types and things are coerced in JavaScript. So what we take a look at here is what this comes out as is false. And then what we can do with that is we can plus it to an empty array here. When we use the arithmetic operator here, what it does is it does string concatenation. So what we end up with is false plus an empty string, so we get false here. Now this then here comes out as 0 because it's in the array square brackets, so this is then translated to 0. So that's how we get f as the first value of the string false. Really confusing, but that's how we do it. And then it's got a load of other examples here of how you can get different letters. Obviously, as we have false here, we can get the F and the A from that and the L. But then when you need an I, we have to do the undefined bit here using this stuff here. Very confusing stuff. There's a website that's really cool that will show you how you can make your own version of these. And that's what I've done here, down here. So when we run this one, this actually is how we can print out the text subscribe without using any of the characters themselves. Really cool. And again, I highly recommend you subscribe for more awesome front-end content. Next one that may have caught a few of you out is adding arrays. This one's quite simple, but we do an array 1, 2, 3 plus an array of 4, 5, 6. What are we going to get out? We're going to get the string 1, 2, 34, 5, and 6. And you may be able to see why this is. Essentially, when we're using the arithmetic there, all it's doing is converting this to a string. So when it converts this to a string, it converts it to 1, 2, 3. And then it's adding this converted to a strings 4, 5, 6. So then these two get bundled together, because obviously we get rid of that square bracket when we converted it to a string. And that's why we end up with this output here. Another really funny one in the spec for JavaScript is if we do a number bracket, so if we convert nothing to a number, or if we convert undefined to a number, you actually get a different value out, even though you would think this here would be equal to undefined, as we haven't passed anything to the number expression here. But again, it's just a thing according to the spec that if no arguments are passed into the functions, then n is plus 0. Otherwise, let it be equal to the number of the value. So in the case of undefined, this should return not a number, but when it's like this, it should return 0. Just another quirk of the spec there. Next one is trailing commas in array. Now, I don't really know the use case for it, and you'd be caught out by this, but it's worth noting. Obviously, if we start an array here and we add commas, what we have here is technically an empty value, an empty value, an empty value. Now, you might expect there to be another empty value here, so you might expect this to be an array of 4 empty values. But because this is technically a trailing comma, as there's nothing after it, JavaScript sees that and gets rid of it because it knows we're dealing with trailing commas here. And then it's just going to make the array actually only 3 empty values, as it doesn't consider the one after this trailing comma here. The next one is we can actually use object properties and arrays. So in here, what you'll see is we've got an object that says hello world with property here. And then when we have a nested array that has property in so many different arrays, so it's a massive nested array, we can actually then use our selector of a nested array on the object, and it's still going to get property out. That's because it's going to convert all of this to a string. And when we convert all of these arrays to a string, it's actually just going to get the first type here, property. So all we're doing when we pass it into object is essentially just passing through property. It just looks really complex because we've nested it in about 10 different arrays. Next one that's caught a load of developers out, and you see some funny examples of this online with stuff like phone numbers, addresses, and different things, is the default.sort. So we have 10, 1, and 3 here, and we sort it. You might expect it to come out as 1, 3, and 10. However, it doesn't. It comes out as 1, 10, and 3. The reason for that is it always converts everything to a string, and the default sort is based on strings. So if you actually wanted to sort all of this based on the actual number values, you'd have to pass in a custom sorting function. And as I said, I've seen so many different examples of this. For example, when you have addresses and things where people have used the dot sort and it's not coming out correctly. Next one is that the minimum value is technically greater than 0. So the lowest value you can get with number.min value is actually larger than 0 itself. This does actually make sense, as it says here. The minimum value here is obviously that really small number. However, it's the smallest positive number that can be represented within a float that's as close as you can get to 0, but not 0 itself. So that's why technically number.min value is greater than 0 itself. If you wanted the overall smallest number, as it says here, you can use number.negative infinity, although that's not really a number technically. The next really funny one is that math.max is less than math.min. So math.min is greater than math.max. A bit confusing there, but essentially math.min, when it's called without any arguments, it returns infinity, and math.max returns negative infinity. So it does make sense here because we're just saying infinity is greater than negative infinity. Again, another weird quirk of that spec there. Another example we've got here is null and 0. So we have null is equal to 0. That's going to come out as false. But null, however, is greater than 0. That's also false. But null is greater than and equal to 0. So how can null be greater than and equal to 0 or equal to 0, but it's not greater than 0 and it's also not equal to 0? Bit confusing, that one. As it says here down here, it's not equal. Null greater than. Basically what's happening here is when we do null equals 0, null isn't equal to any other value, so you get false here. However, when we then do a sort of math expression here, so we say whether it's greater than 0, null technically becomes 0, so null isn't greater than 0 because it's equal to 0, and that's why this one down here comes out as true, because null in this case, when we're using greater than or equal to, it comes out as 0. Again, another bit of confusing spec stuff there. Next one is parsing can be an absolute mess. We console log all of these, you'll see we'll get not a number if we pass this in. So if we pass this string to an int, we get not a number. However, if we use this Regex operator here of 16, we get the number 15. Now, this is how parseInt actually works. When you pass it a string, what it does is it keeps going until it hits something that it can't convert. Now, since the default Regex number is 10, it's going to try convert it using base 10 number system. Therefore, it stops parsing immediately because f isn't in the base 10 number system. However, when you pass 16 to the parseInt function, what it does is it then uses hexadecimal to convert it, and f is in the hexadecimal code, and f equals 15 in hexadecimal, but then it stops at the asterisk here because it can't convert that. So we actually get the value 15 out. Very confusing, but as I said, there's a bit of an explanation here. Now, the other one is if we passed the string infinity, and this one is an absolute chaotic mess, as you can see here. You get not a number, 18, 18, and just a load of different values. But again, the explanation is pretty similar to before. For the Regex values 10 to 18, it's not a number because infinity, none of those characters are in any of that base number system. When it goes 19, it can then successfully pass different levels of the string there. So then it gets different numbers out. And as I said, it's just a bit of a mess that you've got to keep in mind when you're doing it. Another one as well is if we pass an int with some floating point numbers here, what you'll see is we get 0 for that one, but then we get 1 for this, and then we get 5 for this, which seems a bit odd. How is this being passed as 5? And again, it's because parsing expects a string. What it does is it then converts this to a string. However, when we convert this number to a string, what you actually get out is you get the 1e minus 7, and that's why it then gets to 1, and it says, hey, the value's 1. It can't convert e because we're using base 10 system, so it returns 1. And the same thing happens here. As you can see, 1 over e is interpreted as 5 dot to the e minus 7, and then, as I said, it will get confused at the decimal point here, as that's not in the base 10 number system, so it will just return 5. So again, always make sure you're passing a string. And now what you might notice here as well is that TypeScript's actually picking up on these errors for me. Next one is floating point numbers. You've probably run into this before. It's an absolute pain in JavaScript and any language that uses the floating point number system. And that's that it's not exactly precise on 0.1 add 0.2. You actually come out as 0.3.00004. And there's actually a really funny website that is literally this problem, and it's just the URL is thenumber.com. Next one we get using the same sort of floating number point issue is if we did this plus 1.1, we would actually get 2 at the end of this, even though you might expect that to be 1.1. And that's because when we get this high, it rounds it to the nearest even number. Next funny one is if we compare 3 numbers, it doesn't really do what you'd expect. So here we get, obviously, when we have 1, we're saying, is 2 greater than 1? Yes, it is. And then we're saying, is 3 greater than 2? That's all true. However, if we do the reverse, although it's not really the reverse, but we did this in a different way, so express this in a different format. So we've said, is 3 greater than 2 and 2 greater than 1? You actually get false, even though it's technically the exact same expression. And the reason for that is just how it's evaluated here. So what you get out here is you first get true, and then it says, is 3 greater than true? So then true gets converted to an integer, so true gets converted to 1. So then all this ends up doing is it converts this to 1, and it says, is 3 greater than 1? But when we do it on this side, we have, is 3 greater than 2? We have true, so then this converts this to a 1, and then this function then becomes, is 1 greater than 1? Obviously 1 isn't greater than 1, it's equal to 1, so that becomes false. So it's just another weird quirk of how sort of the types are coerced and the order it does it in. Next one we've got is a bit of odd math, so you may have seen this before. So obviously 3 minus 1, that's 2, 3 plus 1, that's 4. And then if we do 3 minus 1 here, we'll get 2 out again, but again, we're using a string. But then if we do 3 plus 1, we get 31. And that's due to how the arithmetic expressions are done in JavaScript. Essentially here, obviously it knows it's doing the minus, so it's just going to make it a number on a number. When we do plus with a number and number, it's just going to use math again. But when we do this, it's going to convert 3 to a number, and then obviously 1 is already a number, so we can get the value 2. But if we have a string, it knows it can do string concatenation, so it actually converts 1 here to a string, and then adds the strings together, and that's why we get 31 there. And then there's just some really other like cool examples. If we have a string of 222 and a string of 111, but then you use minus minus instead, it can actually work out that that's a number, and then it gets it out there like so. The other last final one is that string isn't actually an instance of string. So the type of hello is string, but hello itself isn't an instance of string. And again, that's just really confusing, but essentially it's in the spec that a string literal just creates the primitive string value, but it doesn't actually create an instance of the string object. And then the type of operator correctly identifies the type of string as string, but the instance of operator returns false because string isn't an instance of the string object. Again, another really confusing one. You probably won't run into this, but it's just quite funny that essentially it's saying here that this string here isn't an instance of string itself. There you go. There's a load of examples there, and I'm going to leave a link to the GitHub repo where I found loads of these called WTF.js, and it has so many more. Let me know what your favorite quirk of JavaScript was, and have you run into any of these issues when you've been coding yourself, and it's been a nightmare to debug until you found out that it was a bit of a quirk with JavaScript. And as always, please subscribe for more.